I think now you can. So I think now we are recording. So now, so I was saying that a class is a blueprint for object, or class is a template for object, and the two can go hand in hand because you cannot talk about one without the other one. So when you talk about a class, also there is a object. When you talk about object, there is also a class. So the class describes the type of objects. This is another good simple way to understand the class. Just a simple type of object, and the objects will be like a usable instances of classes. So those are very important keywords. Each object will have the same set of blueprints, and therefore contains the same components. They have the same properties, the same method. The standard meaning is that object is instance of class. Object is instance of class, and object have states and behavior. States and behavior. Of course, we talk about the state when you look at the parameters, the properties, methods. So those will explain the behavior of the class. So let's look at the example. A dog has like a 3 state. The color can be different, the name can be different, and the breed can be different. So on the behavior can be the dog is wagging, the dog is barking, the dog is eating, those are things like that. So eventually you can have a different dogs, but still they're all dogs. So let's look at this one. This is a basic class, is dog, and we can have a Bobby dog. A Bobby dog, in terms of property, you can see the class has no state, but here we have the state. So the color of dog is yellow. The eye color of this dog here is brown. The height, there is no state here, but here the height is 17 inch. The length is like there's no value by the way, but here you have like a 35, and the weight here there is no value, 24. So now you can understand. So from this one class, we can create a number of classes. From this class, we can create a number of classes. So I think that's why we say that a class it's like a template, and the object is like an instance of the class, because it can have so many dogs with different values here. That's why we say instance you have a state and the behavior. Like this dog is sitting, for example. Then you can have a dog which is walking. You can have a dog which is so there's so many different things. So the key notations when you create a class, we have some key concepts we use. Attributes to illustrate the state, and the behavior will be illustrated by operations or methods. Okay, so and every operation or every behavior has signature. So when you talk about signature, you understand in programming, every function, every method has what you call signature. Signature means what? The return type, number of parameters, the name, whatever. So the only thing which is like a mandatory information is to have the name of the class. So let's look at this simple example. We have a class named as shape, and you have like one attribute which is rent, and you have some operations or methods. You can set length, you can get length. So why do we use the plus? Why do you use minus? Anybody? Because I think you guys you read this notes before. So you remember when we talk about the access modifiers, something can be public, something can be private. So in that case, we use when we go to use the case diagrams, we use the plus and the minus. So minus stands for what? Plus stands for what? Let's see. So minus stands for private. You can see, and the plus stands for public. Okay. So you need to pay every single attention on this stuff. So the name of the class will be in the first partition in the first room. The properties will be in the second room, properties or attributes, and the operations or methods will be in the third room. So this is a class. If you go to the this is another class, by the way, but then we add even the signature. So signature means what? Like this length is going to be integer, get length is going to return integer, and the set length is going to take some parameter. N as a parameter of type integer, and is going to return nothing, void. So this is what you call signature. You know this from programming perspective. And you can check the meaning of each of the symbol in the above diagram. So let's look at some good examples of class. Do we have some examples? Yes, here we do. And we can do at a conceptual, at a logical, and at implementation level. So this is the same as the concept of database at different layers of abstraction. So conceptual means what? Represent the concept in the domain. Here we don't have a logical, we have what you call specification, which will focus on the interface of abstract data type. So focuses on data types, and implementation, which refers on how the classes will be implemented, how the class will implement the interface. So let's look at this example. So we have like a cell. So at the conceptual level, you can have either of the two partitions, one with a class name, or simply you can have a class like this one. So this is at the conceptual level. And the next two, this is at the specification level. So you can specify the class, attributes, and methods, and also you can indicate the parameters, whatever. Then implementation means what? The way these classes will be implemented in your program. So you can see includes also the signatures. So not very important, maybe up to here it's important, but still it's good to know everything. So in terms of relationship, you will mainly see one straight line, which is association. This is the simplest relationship. Two, you will have inheritance, which is indicated using arrowhead, which is not shaded. You see, this is inheritance. But also we have realization. Eventually, inheritance and realization goes hand in hand. But realization is mainly for interfaces, because now you know the difference between interface and the inheritance. So for inheritance, we use this relationship. For inheritance, we use this type of relationship. So dashed line with the other head, which is shaded as well. So we have another one, which is like a dependence. When a class depends on another class, for example, again, this relationship will be denoted by dashed line with open arrow. Then the two important one, the last ones are very important. So this is what you call aggregation and the dependency. So did anyone learn about aggregation and decomposition before? Aggregation and decomposition. Anyone?
No, teacher, and I think it is better if you give us some explanation about these two.
All right. No, of course I will give, but I wanted to. It's always good for us to ask some questions, because we need to know if you already know this or if this is just new. Okay, so now let's try to focus on this one, aggregation and the composition, because By default, you guys will use association. So as long as you have like one class and you simply link the two classes, this simple relationship is what you call association. And inheritance also you should know, because like if you say in my class I have I have a class of users. This is an example. So this class of users will store the information about the student, the teachers, administrators. So like a student class, like a teacher class. I think you understand what I mean. Like administrator class, admin, of course. So the concept here is that those classes are subclasses of users. So that's where we do inheritance. The same goes for teacher. So teacher is a subclass, and even student is a subclass. So this is a concept where we use inheritance. So association, inheritance, aggregation, and decomposition will be mainly used. So we can read the definition of aggregation and decomposition, but I want to give you a simple explanation. So what is aggregation? So there is a concept of part. And the concept of whole, the whole. So something is a part of the whole, the whole. So let's say, what is that? Okay, we can use the concept of looms. Looms and the house. All right. So a house represents the whole thing, and a loom represents part of it. So then we can say a loom. Okay, we can say a house is composed by the looms. You understand? So let me know please if you don't understand. A house is composed by, so which we use diamond shape here. A house is composed by, but I'm reversing it actually. So this is a house, this is a room. Okay? So you can say a room is a part of the house, or house is composed by the rooms. So for both aggregation and decomposition, we use the same notation, but we put some difference by shading this diamond shape. So the question is, when when aggregation becomes a composition. Composition is a strong aggregation. Strong aggregation. What does it mean? So in a simple and easy way to understand, aggregation becomes a composition if the part will cease to exist if the whole does not exist. Very simple example. Can a room exist without a house? So let's imagine you have like a house of 10 rooms, and maybe you destroy your house. Will the room still exist without a house? Answer is no. Okay? So that means this is a strong aggregation, and the strong aggregation is what we call composition, because the room cannot exist without the house. But let's look at the page. Let's look at the page in your notebook. Okay, let's look at the paper, not the page. Let's look at the paper in your notebook and the notebook. So these papers, the combination of those papers will make up a notebook. Okay? So the combination of the papers will make a notebook. Now the thing is, if there is no notebook, will still the paper exist on its own? I think the answer is yes. So this is what you call simple composition, and simple composition is aggregation. Strong aggregation, it's a composition. So I don't know if I've answered your question, but that's how you differentiate between aggregation and the composition. So can I give you another one example? Let's look at Look at your hand. Your hand has how many hands? This is a hand. How many fingers? You have some fingers, right? Yes, Shimwe, you can go ahead, please. Huh? Ishimwe Josue, so please go ahead. So you have some fingers, and those fingers will make up the hand. So now the thing is, can finger exist on its own? No, finger cannot exist on its own. The existence of the finger will depend on the hand. If the hand is there, the finger will be there. If you cannot take the finger away from the hand, and this finger continues to exist, that means the relationship between the two, it's gonna be a composition. Okay? Yeah, so let's get the question from Ishimwe. So you can feel free to ask your question.
So I was not getting with the aggregation, but now for that example I understand. Thank you.
Okay, good. All right, so let's look at some other examples then. Okay, now you can see the inheritance, for example. You know the shape. A shape could be like a polygon, it could be like an ellipse, could be like a spline. So that's why you see the relationship here becomes inheritance. So in your class diagram, you might have these examples. So there are two styles. You can go with this style, but this will create so many arrows, or you can go with this style. So to me, I think the second style is good. You can go with the second style. Let me remove all this stuff so that you can see. All right. So association, as we said, this is the simplest relationship between the classes. Just a simple solid line between the classes, and you give it a name based on the verb or verb phrase. Simple. You can have a simple association, which is a line between, straight line between the two peer classes, like class 1, class 2. I want to find the good examples. So you can include the cardinalities. Cardinalities means what? The number of instances participating from each end. Can be 1, exactly 1 from one class. Can be 0 or more. No, 0 or 1. Also can be 0 or more when you use a single asterisk. Can be 1 or more. You can have order the classes, order the relationship. So which means if it's from here to there. So when you see those numbers indicate the cardinalities. Cardinalities means what? The number of instances from each class to participate in the relationship. So aggregation, as we said, there is a keyword called the part of relationship. If class 2 is a part of class 1, you can use aggregation. You can have many instances as well, things like that. So we indicate it using arrow with diamond shape towards the whole class. And the composition is a special type of aggregation where you can see this keyword. If the parts are destroyed, the parts will be destroyed when the whole is destroyed. So I was saying, for example, if you cut off the hand, the fingers will cease to exist. So that's an example of a composition. In other words, you can say the other class cannot stand by itself, cannot exist on itself. So class 2 will live and the class 1 will die. Okay, will live and die if the class will live and die with another class. So the relationship between those two classes is a strong aggregation, which is a composition. So the finger will live as long as the hand is there. The finger will die as long as the hand is died, right? Okay, so that's aggregation, and I'm hoping we can get some clean examples. Realization, maybe come to the examples. Is the relationship between the blueprint class and the object containing its perspective implementation level of details. I think, as we said, when you have a concept of interfaces, realization becomes very important. Okay, so now let's see. This is another example for realization, and for more explanation, this is simply explaining every component, class, multiplicity or cardinalities. The relationship is a simple association. Here it's a simple aggregation. What is here? This relationship. So if you don't remember the name of the relationship, I think this table will help you a lot to understand the names of the relationship. So if there is any straight line, actually it's inheritance, and the dashed line, it's either realization or importance. So we have 10 minutes to finish this, and once we finish, we come back and use a Google Meet. All right. So activity diagram, yes, we know activity diagram in UML. We will use activity diagram. Let me see if I can upgrade this meeting, because it says upgrade. I did it before, but I was not upgraded. Okay. Address, why? Chigari. Okay, just few seconds. Rwanda. Okay. Postcode 00. I want to check if select total employees. Just me. Okay, let's see. It's okay, let's continue. So in the 10 minutes to come, maybe we'll go for Google Meet. So activity diagram is similar to a business flow, workflow diagram, or simply flow chart. But this one has much richer information and meaning. That's what we call semantics. So it describes the system activities, or a person who does the activity, and the sequential flow of those activities. So the activity diagram is one of the UML diagrams associated with the object-oriented approach, and it can be used in any other software development paradigm. So you should not limit yourself to just object-oriented approach, because the flowchart can be applied to any programming style. So you can see it explains the flow of the sequence. This is like a process called process order. And the explanation here is how the process order can be carried out. So it shows there is what you call initial node, that is the start. So you start by receiving an order, and this is what you call action. So once the order is received, this is object flow. So the object which comes, it's order, which comes as a document, whatever. This is object node, and this is the flow. The arrow means the flow, and you can have like some indicators like a guard. So see something here, it's like a condition. order is accepted or order is rejected. If it is accepted, then people will fill the order in the system, and this indicates what we call it fork, by the way. Fork means so many activities can take a place. So here this guy will send invoice to some people, and also will send the shipment order. So these two can go in parallel. So we use this type of stuff. This is called the fork, and once you finish, this is called the join. So this activity will complete, and invoice will be sent, the payment will be received or accepted, and everything will come again here. So this is the join node, and from a join node, there's what you call the kind of magic. Put all those things together, and of course the order will be closed, and this will be known as a final activity. This will be known as a final activity. Okay, so I think this is a complete diagram. It has a lot of elements. So you might need to create a use case, activity diagram with not all of these elements here. But in summary, you use the use case, activity diagrams to explain the process. And it's very important, if you learn the concept of swim lanes, how do you spell it? So it's spelled like this one. This keyword is very important, swim lanes. So when you want your activity diagram to be clean and clear, swim case diagrams will be very important. So how does it work? You separate the actors. All right, like this one, it's something to be done by front office people. This is something to be done by warehouse team. So now you can see the demarcation. If you see any activity here, this activity is done by these guys here for this specific maybe category, and any task that you see here, it's done by the people that you see here. So this is the concept of swim lanes, and I think we can end up here because we remain with like a 3 minutes, and so let's finish by here. Then we go to Google Meet. So can you please check in your chat room? There is a Google Meet link. Can you check and join? So for here we'll be stopping, and maybe we can explore the tools using Google Meet, because we can be able to share more tools, I'm guessing. Otherwise you cannot share the tools with Zoom. Okay, so guys, are you there? So next time, maybe for the Meet the same, we can cover up to there. But next time we can look at a state diagram, and after state diagram we can look at what is this state diagram. Let me check the other diagrams. State diagram. Oh, it's a lot for state diagram. Oh, it's a lot. State diagram. What else? After state diagram, we look at. Let me check. So I think it's state diagram. We have a deployment diagram and the package diagram. So we might also think of functional diagram. So maybe next time we'll introduce those two diagrams. They are very important as well. But as I said, the sky is the limit. You can keep exploring more and more. But definitely we can take you through those ones. So let's go to the Google Meet. Let's end this one by here and go to Google Meet. Can you send again the link? The link is in the chat room, by the way, so some people did not see the link. The link is there. Check the chat room. All right, so let's stop by here and meet again in 5 minutes in Google Meet, not here. So let me stop.